Hello, and thank you for taking time to listen to this presentation and application for the Abbott Innovative Product Award for FlowCrete Single Pass Pressure Pipe. My name is Pitzer, and I am the Director of Trenchless Markets for Thompson Pipe Group. I'm excited to present FlowCrete for this award because it truly embodies the spirit of the Abbott Award. It was born out of necessity and has recently been redeveloped and deployed on two groundbreaking projects and highly challenging projects in the industry with success. FlowCrete is a first-in-class composite pipe designed to meet the strict requirements of jacking and microtunneling installations for both pressure, water, and sewer applications. It combines the compressive strength of reinforced concrete with the corrosion resistance and pressure capabilities of Thompson Pipe Group fiberglass pipe. This composite pipe incorporates an outer load-bearing wall of reinforced concrete and a structural inner liner of Thompson Pipe Group fiberglass pipe. The wall thickness of the concrete pipe is designed to accommodate the jacking loads and distances under consideration and the dimensions of the equipment used in the jacking process. The Thompson Pipe Group fiberglass liner is built to withstand the required internal pressure and the corrosive environment of sanitary sewers and similar environments. The pipe is compatible with standard wooden packers and hydraulic compression rings when required. The earliest case study I could find using the concept of casting a fiberglass pipe inside a concrete jacking pipe was for a project in Berlin, Germany in the 90s. This is the joint on the top left. This joint seems overly complicated, and I believe it would be harder to produce than the FlowCrete joint. When Thompson Pipe Group first developed FlowCrete for the North American market in 2012, it was developed for the Big Lake Gravity Sewer Project in Edmonton, Canada, which won the 2013 Northwest NASTT Project of the Year. This is the joint on the bottom left. The project was initially specified as a fiberglass jacking pipe, which is a flexible pipe product. The soils were extremely poor with a zero blow count in some locations, so a rigid pipe was required for these ground conditions. Thompson Pipe Group at the time developed their prototype of FlowCrete in North America for this one-off project, so the contractor could still install fiberglass for the corrosive sewer environment, but in a single pass versus a two-pass operation, with the reinforced concrete as a casing and FRP as the carrier. Though Thompson Pipe Group has long provided trenchless products, in 2021, Thompson Pipe Group started a focused trenchless division to serve the trenchless market. With a national footprint of plants capable of casting concrete pipe, Thompson Pipe went back to the drawing board and further developed the joint and the pipe so that it could be used in pressure applications, curved drives, and drives with high external waterhead. FlowCrete's unique and overall value is simply the reduction of a three-step installation process into a single step. FlowCrete utilizes two independently structural pipes combined into one to form a composite pipe that outperforms the best qualities of each independent pipe system. Fiberglass pipe is inherently corrosion resistant and can handle pressures up to 450 psi, making it ideal in sewer and pressure applications. Reinforced concrete pipe is a rigid pipe, and when manufactured for microtunneling using the wet cast method, makes an exceptional microtunneling and jacking pipe for the following reasons. It's a rigid pipe, and it maintains its round shape as it's jacked. Wet cast manufacturing method produces a smooth outer wall, which leads to less friction between the pipe and the earth, and hence lower jacking loads than a dry cast pipe. The large bearing area at the joint on a thick-walled pipe means higher allowable jacking loads, and that large bearing area for thick-walled pipes also allows the pipe to be pushed through tight radius curves. While it has all of these benefits, RCP is not the best pipe for use in high-pressure applications or highly corrosive environments. FRP, while great for corrosive environments and pressure applications, cannot be pushed through tight radius curves or support itself in very poor ground conditions without ground improvements. By combining both pipes together, you get a highly effective pipe that can be installed in a single-pass installation, where typically a two-pass installation is designed to install two different pipes to handle the varying conditions. Currently, FlowCrete does not have a direct competitor in a product. Rather, it competes with the two-pass method of installation. As I just mentioned, the two-step process installation takes 3 steps to complete, which you can see on the bottom left of the slide. This includes installing a casing pipe or ground support, then inserting a carrier pipe in the second step, and finally grouting the annular space. Because you need room in the casing pipe to install the carrier pipe, a casing pipe for a two-pass method has a larger outside diameter than an equivalent FlowCrete for the same internal diameter. The example shown here is a 72-inch ID fiberglass pipe. With FlowCrete, the OD of the concrete pipe is 87.5. To install a 72-inch fiberglass pipe inside the casing, you would need an 84-inch reinforced concrete casing pipe for a curved installation. The OD for the 84-inch concrete pipe is 101.5 inches, so by using a single-pass FlowCrete pipe, the outside diameter is reduced by 14% in this example. So not only are you reducing the number of steps, you are also requiring smaller excavation, which means using smaller MTBM, which reduces cost. Eliminating 2 steps also reduces the pipe material required and reduces the schedule required to install the pipe. The reduction in pipe size, schedule to install, and earth excavated creates a smaller installation footprint than with the two-pass method. Shaving a few weeks off of a construction schedule dramatically reduces all the emissions and energy used for pickup trucks, dump trucks, cranes, generators, and other project equipment. The shorter project schedule has many positive impacts, including a shorter disruption to the community and shorter duration that personnel and equipment are required on site. This leads to significant cost savings in all the items above. Finally, FLOWCRETE has a 100-year plus design life, which means it has a low life cycle cost and will serve communities well into the future, so that they can take care of fixing and installing other underground infrastructure. And finally, for the bonus slide, I want to highlight a couple of successful projects completed in 2023 and 2024. First, the Bay Park Force Main project, which started in 2021 but took a couple years to complete due to the scale and size of the project, finished tunneling at the end of 2023. This was located in Nassau County on Long Island in New York. The product is a 72-inch diameter, designed for 150 psi surge pressure microtunneling pressure pipe. It contained about 3.6 miles of 72-inch pipe installed over 12 drives, and the contractor was Northeast Ramsco Construction. The photo on the bottom left is one of the MTBMs holding out in the reception shaft, and the photo on the right is one of the longer drives in the project that included a curve and was a single push a little over 2,200 linear feet. The project on the right is the Tri-City Outfall Project. This is located in Oregon City, Oregon, and is an outfall that's tapping into the Willamette River. This is a 90-inch FLOWCRETE microtunneling pipe. The drive was just under 2,400 linear feet and was a single drive that included 4 curves and 5 intermediate jacking stations and was installed by Michaels Construction. Both of these projects were groundbreaking in their own way. For the Bay Park project, it was the first time that FLOWCRETE was installed in the United States, let alone on such a large scale. The project on the right was unique in the fact that it had 4 curves in a single 2,400 linear foot drive. I haven't been able to find another project that has 4 curves in a single drive in the United States. Thank you for listening to our presentation and award application for the Abbott Innovative Product. And if you have any questions, please feel free to reach out to me at cpitzer@thompsonpipegroup.com. Thank you.